Hello students, welcome to one more amazing session from NEET YouTube channel. Here, one short session from each and every topic from the total NEET chemistry syllabus is on. So, आज हम चर्चा करने वाले हैं electronic effects from the general organic chemistry, some basic concepts and principles in the organic chemistry grade level. So, the importance of this chapter is, it is the key point. Today's class is going to be the key point for the entire organic chemistry. Let it be hydrocarbons or haloalkanes and haloarenes, alcohols, phenols, ethers, and you also see the carbonyl compounds, amines. Even in the biomolecules, the effects, electronic effects is the key point to decide any chemical reaction in the organic chemistry. So, while it will start the electronic effects. So, what are the electronic effects? So, it is the principles of organic reaction mechanism. You guys says the organic reaction mechanism is exactly required for NEET examination. Yes, it is required. Every question that you answer in any chemical reaction in the organic chemistry has to be cracked by virtue of electronic effects and mechanism. So, you need not have to write the entire mechanism during the entire chemistry paper. But while preparing your NEET examination, you just focus the mechanisms and you just come out of this what exactly it is required at the end of the mechanism, and based on this outcome of the study of the mechanism, you have to directly apply without doing mechanism. You can do the best in the organic reactions in the NEET examination. So, let us start what are organic reaction mechanisms and how it can be done. So, what is a mechanism? So, organic chemistry you study, in the organic chemistry reactant is going to give rise to the product. While the reactant is converted into the product, so reactant is actually a molecule. Old bonds are present in the molecule. So, that old bonds has to be broken into the molecule so that it has to give the intermediate. And that intermediate is going to change to the product. So, in the scenario, reactant is converted to the product. In the reactant, old bonds are broken. In the product, new bonds are established. So, what reaction mechanism here? A systematic study where the old bonds are broken, how old bonds are broken, why old bonds are broken, and how new bonds are established, and that is given by the intermediate. So, we will start various types of the intermediate here, how the old bonds are broken and how new bonds are formed. That is the basis of the organic reaction mechanism. So, for that I just want to discuss the bond breaking. So, in the organic chemistry you see various bonds are broken. So, the bond breaking is of two types, homolytic fission and heterolytic fission. Breaking of the bond is called fission. So, if the bond is exactly broken to the half, it is called as a homolytic fission. If unequally broken, it is called heterolytic fission. Let's talk about homolytic fission. Let's say, and the heterolytic fission, let's talk about an element A and B. So, there is a bond pair of electron that is present between A and B. So, the bond pair is exactly broken to the half. So, that is called as a homolytic fission. When it is broken to the half and the bond is going to be shifted here, and this is called as homolysis. ताकि आपको मिलेगा ये dot and B dot. So, these are called free radicals. So, any book can tell you, but there is a key point. So, let me complete what is heterolytic fission. Then I will come up that trick between the homolytic fission and heterolytic fission. Let's say A is an element and B is an element, and assume electronegativity of B is greater than A. ताकि इलेक्ट्रॉन पेयर बी तरफ जाना को ज़्यादा कोशिश करता हो तो the bond is broken unequally, therefore you are going to see the electrons is shifted more towards the B. So it is going to give you A plus and B minus. So you are going to get a cation and you are going to get anion. So in this scenario, so when the homolysis takes place, when heterolysis takes place. So that is the key point. So I want to give you what exactly the reason behind the homolytic fission. In the homolytic fission, it is more energetic and it takes place in the presence of light, it takes place in the presence of peroxide, it takes place in the presence of vapor phase reactions. Vapor phase reactions, whenever the temperature is about 750 Kelvin or so, the free radicals are more likely to generate. While in the case of generally in any kind of chemical reactions in the organic chemistry, heterolysis takes place and only in these given three cases homolysis takes place. And heterolysis takes place in the presence of maybe aqueous or aqueous solvent or polar solvent, any polar solvent, or it may be acid base reactions. In the presence of acid or base reactions, you are going to get heterolysis. It is a less energy consuming process. So whenever you have the free radicals, you have the carbon free radicals, that you can say carbon free radicals, and you can say carbocation, and you are going to get a carbanion. Now by using electronic effects, we are going to use the order of stability of this carbocation, carbanion and carbon free radical. So that when you just go through, the reactant gives rise to the product. This is the intermediate, chahiye intermediate carbo free radical ho sakta, carbocation ho sakta and carbanion bhi ho sakta, and benzene and nitrine, carbene, these are all the other category of the intermediates, but these intermediates we don't see in a regular basis. We see only major three types of the intermediates. So I wanted to say, during the conversion of the reactant to the product, more the stable the intermediate, it is going to be, the more product is going to be formed. When you see a chemical reaction, you are going to see this is a major product and this is a minor product. And the major product, how do you say a major product? A major product can be derived from the more stable carbocation or more stable carbon intermediate. Let it be carbon free radical, carbocation or carbanion. Most of the cases these three are seen. And moving ahead, what are the effects that stabilizes the carbocation, carbon free radical, carbanion and their acidic strength and basic strength? So without delay, we are going to enter into the details about the electronic effect which makes them stable. So dear students, this one short video can give you the total information about the electronic effects in today's class. So everybody take a pen and paper, write the concepts along with me. Meanwhile, I am going to give you little short tricks and tips that can help you a lot and you can do the best. So dear children, please like this session, share with your friends and subscribe to this Infinity Learn NEET YouTube channel. So my introduction part is completed so that we can do the best for the electronic effects. Here let us talk about this homolytic fission and heterolytic fission is completed. But so let us talk about the carbon intermediates here. So carbon carrying one electron is known as carbon free radical. Carbon is going to have sp2 hybridization. There will be unhybridized orbital and it undergo sp2, odd electron will be there. Carbon is having 7 electrons with it. It is not satisfied with its octet. When you talk about carbon carrying the electrons, both the electrons is known as a carbanion. It is going to be carbon sp3 hybridization and it is octet. This is what is called as a carbanion. It is sp3 hybridization. It is 8 electrons. Talking about carbon carrying the positive charge is known as carbocation. Their carbocation, just like carbon free radical, it is going to have sp2 hybridization, and it is having a vacant orbital. So here orbital carries odd electron, but here it is a vacant orbital, it has 6 electrons. This is electron deficient, it is electron deficient, and whereas a carbanion is going to be electron sufficient. So it follows the general order. Carbocation stability and carbon free radical stability, both are going to be the same order we follow, while you can see the opposite order for this carbanion. चाहे इसको carbocation let us say. So tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. It is true in the case of the same order for the carbon free radical as well. So when you talk about the stability of both carbon free radical and carbocation, you say tertiary is more stable than secondary is more stable than primary. While you talk about this anion, so primary is more stable than secondary is more stable than tertiary. It is a generic version of the stability. But when it comes to both carbocation and carbanion, benzyl is always greater than allyl is always greater than alkyl. So it follows the same for these three. So any factor which stabilizes these factors, we have to see in the electronic effects. So electron displacement effects, it is the main course for today's class. In this main course, you have majorly inductive effect, electromeric effect, mesomeric effect and hyperconjugation. 4 types of electronic effects I can say. So in a molecule, to decide its stability, to decide its order, or maybe acidic order, basic order, stability, reactivity and everything, you have to include these 4 points. So in a molecule, maybe 1 point or 1 effect or more than 1 effect can be applicable. So which effect has to be given more priority in order to decide the electron displacement effect. So I want to give you a simple thing here. Hydrogen bond is super effective as compared to steric effect is more effective than aromatic effect is more than mesomeric effect or resonance effect is more than hyperconjugation is more than inductive effect. बच्चों, you don't say sir cheating किया यहाँ पर. No, I have written 4 but I have written many. उसमें क्या फर्क पड़ता? देखो, you can say hydrogen bonding, steric effect and aromatic effect are physical effects. And mesomeric effect, hyperconjugation, inductive effect are electronic effects. So here the list is given only electronic effect. और एक चीज है, सर again you cheating. Electromeric effect यहाँ पर लिखा नहीं बेटा. Why I did not write? Electromeric effect is the strongest effect actually, but it is a temporary effect. As long as the reagent is there, it is going to be present. If the reagent is taken away, the effect is disappeared. That's the reason why I don't want to include electromeric effect. Yeah, alag likhna hai. Without your intention also it will take place as long as the reagent is there or not. Now, so what are the takeouts from this particular expression? Whenever hydrogen bond comes, no effect works. It takes over everything. And steric effect, whenever you say a methyl group or ethyl group, due to bulky nature, it is going to hinder. So because of that, electronic effects are going to be diminished. So I will discuss what about the aromatic effect and all, and we'll have the discussion about that. So mesomeric effect and hyperconjugation inductive effect. I will tell you the game over here. Inductive effect is the first effect we start because it is there in the every book. It is there in every first class of the organic chemistry. ये देखने का अच्छा होगा, explain करने का अच्छा होगा, and our interest will be at the top. Because of that interest and because of that impact, you guys study inductive effect so generously, so effectively, and whenever you see a particular question, you look at that particular question in perspective of inductive effect. But inductive effect is the weakest effect, and the other effects you actually has to visualize it, which is not actually visualized. Therefore, here is the only one point the student is going to miss. So, inductive effect is the weakest effect. Psychologically tune with yourself, right? So, without delay, we talk about all kinds of electronic effects in one shot in today's class. Please take a pen and paper and write all noteworthy points. Okay. So, moving ahead in this inductive effect, we will start. So, what is inductive effect? That's pretty well, it is established. You can see electronegativity is the game changer for inductive effect. So, carbon is tetravalent over here. Carbon is attached with a group. Let us see the nature of this group or atom directly attached to the carbon in the organic molecule. When the electronegativity of that group or the atom is greater than carbon, say example it is halogen. So, what will happen? This carbon, as I said, it is a halogen, it is like this. So, if the electronegativity of this group is less than that of this carbon, let us say this is the one, carbon to carbon bond, it is a group. So, what I can understand? So, as electronegativity of this halogen is more, it is going to have little bit electron is pulled along the sigma bond towards the halogen, it will get a negative charge, therefore, it will be having a positive charge. So, this pull will be little bit accumulated here because it is induced, it is going to get a positive charge, and it is going to be little pulled in this way, and it will get a little more positive charge, that's it. So, the magnitude of this total quantity of the positive charge is equal to the magnitude of the total quantity of the negative charge over here. So, electron is pulled in this direction along the sigma bond, that is what is called negative inductive effect. If you see the other reverse case, electronegativity of the carbon is more, therefore, the electron is pulled more towards this. So, carbon is getting negative charge, is going to get a positive charge, and at the same time it is going to be a little bit in this way, partial positive negative charge and partial negative charge. So, this is the way bond to bond interaction is required for organic chemistry. So, this is what electron is pulled towards the carbon chain, so by this group, so that it is called as a positive inductive effect. If this electronegativity of this group or this carbon is nearly same, electronegativity 2.1 2.5 आसपास में होगा, तो carbon and hydrogen is the bond, you can say. So, therefore, for inductive effect, carbon to hydrogen bond is taken as a standard, क्योंकि carbon hydrogen electronegativity दोनों का बराबर है. So, in the NEET examination, you may be asked a simple question about the inductive effect, assertion and reason. Carbon to hydrogen bond is taken as a standard. Why? Because carbon का hydrogen का electronegativity दोनों का बराबर होगा. So, let us see the details about in the inductive effect. So, the minus I series, negative inductive effect series, this is the order of this negative inductive effect series. Sir, how do I know that? So, do we have to by heart all these things? It is not like that. So, what exactly it want to say? You put this and you put this and compare, and the electronegativity of N plus is greater than, you can see, electronegativity and the negative inductive effect, this is the rule. Look at this electronegativity of the nitrogen with a positive charge, nitrogen with a multiple bond. So, electronegativity of nitrogen is more than electronegativity of nitrogen. So, you have to see in that way. And this is the one where which you can give it. All functional groups will have negative inductive effect, and as electronegativity of the atom directly attached to the carbon chain, it is going to have the more inductive effect. You can see here, chlorine and bromine. Chlorine is more electronegative than bromine, is more electronegative than iodine, and you can see the various order, and hydrogen is taken as a standard. Talking about the positive inductive effect, electron releasing group, ERG stands for electron releasing group, EWG stands for electron withdrawing group. In that, any alkyl group is going to be positive inductive effect. And also, there are only two things, O minus, COO minus, or only the anions will have the positive inductive effect. Now you can see anions are not there, anions are there, they are going to have positive inductive effect. Anion means it is full of negative charge. So they push out this negative charge on the carbon chain. And you know the salient features about the inductive effect. Very important point you need to know here. Important points, that is inductive effect of alkyl groups. Tertiary is greater than secondary, is greater than primary, is greater than methyl group. When you talk about this inductive effect, in general, greater the number of carbon atoms in the alkyl group, greater is going to be the positive inductive effect. Bacho, positive inductive effect is directly proportional to size of alkyl group. Alkyl group meant to be R. Size of alkyl group. Size of alkyl group means it could be number or it could be bulkiness. And you know, for a problem solving, we take electronegativity of sp hybridized carbon to be more than sp2 than sp3. And you just see, when the isotopes are there, deuterium and hydrogen, okay, and heavier isotope will have higher positive inductive effect. Say an example here, CD3 will have greater than CH3. So this is one way you can say. And also inductive effect, it is the weakest effect. Among all electronic effect, first you need to know it is the weakest effect. And also I just want to say here, only sigma bond is operated. What is the sigma bond? You can say the inductive effect is operated through the sigma bond. Hekina? There is no pi bond is involved. It is sigma bond operated. And the inductive effect, first carbon, second carbon, third carbon. After that, inductive effect will not work. So inductive effect is distance dependent. I just want to say inductive effect is distance dependent. After 2 to 3 carbon atoms, the inductive effect can be ignored. And you know, I want to say here, whenever oxygen is there. So oxygen, here it is a carbon, here it is a carbon, here it is a carbon, carbon. You are going to see the inductive effect in this way, like this, like this, like this, and like this. So you are going to see the pulled electron in this way. And if you want to say here CH3, it is going to push the electron in this way, push the electron in this way. So this is how the inductive effect has to be visualized. And one more important thing, a super golden rule I want to give you as far as the inductive effect is there. Whenever inductive effect is there, use DNP rule. What is this DNP rule, beta? D stands for distance, N stands for number, P stands for power. Distance, number, and power. So you have to give the distance, you should be given more priority, then number should be given more priority than the power. So what you guys are learning, these are all the power. So power has a least priority, but student here it is misleaded to by heart this power order which actually doesn't need it. You just observe whether it is having inductive effect. Whenever inductive effect is there, you just observe it is a positive inductive effect or negative inductive effect. So let us see the applications of the inductive effect. So moving ahead, let us see the orders of the various effects. So here the important I already given you about this and applications of inductive effect. So we will see in today's class every application, and every electronic effect immediately its application. So let us talk about acidic strength. What is an acid? So you can say acidic strength. So in this acidic strength, let us say Ha is a weak acid and it is going to give you H plus and A minus. So this is what is called as a conjugate base or conjugate anion. As it is a weak acid, let us be acetic acid. Acetic acid gives us H plus and acetate ion. So acid dissociation constant, let us apply ionic equilibrium here. H plus concentration and A minus concentration. A minus means anion and its conjugate base, and Ha. So this is the acid dissociation constant. You know, as acidic strength increases, H plus ion concentration increases and Ka value increases. You know, the pH is equal to negative logarithm to the base 10 of H plus ion concentration, so that we can say pH is equal to negative log H plus ion concentration. So I want to say if H plus ion concentration is increased, pH will be decreased. Similarly, you have pKa is equal to negative log Ka value. So if Ka value increased, pKa value decreased, and pKa pKb is equal to pKw. So pKb value will be increased. So this is the basic things about the acidic strength. Or otherwise, I just want to give you very important point. Thumb rule for the total chemistry, not only for here organic chemistry but also for inorganic chemistry. Acidic strength is directly proportional to stability of conjugate base. If this conjugate base is more stable, equilibrium always is going to be more towards the forward direction, so that H plus concentration is maintained high, so it is going to be more acidic. So this is very important point. So how do I apply in terms of electronic effects? Simple. Acidic strength is directly proportional to negative inductive effect. Acidic strength is inversely proportional to positive inductive effect. So these are the two things I can help you out of this. Children, this is a very, very important point. Now, based on this, how a question can be asked. Let us see here. Compare the acidic strength of formic acid and acetic acid, propionic acid, and it is going to be 2-methylpropanic acid. So in this case, let us say here it is going to be positive inductive effect. See the size of the I want to write. 1 carbon, 2 carbons, its positive inductive effect is little more as compared to here. Here some more carbon atoms are there. Therefore, inductive effect is going to be some more. Effect is more. So to mention the effect ka intensity, I value chota likha or bada likha or bada likha. Okay, so more positive inductive effect, it is going to be less acidic. So compare the acidic strength. I want to say 4 is going to be less as compared to 3 is less as compared to 2 is less as compared to 1. So this is how. इसके ऊपर कुछ नहीं होगा, नीट एग्जामिनेशन में ऐसा क्वेश्चन आने का संभावना है. You all focus and follow this kind of acidic strength and basic strengths and the fundamentals of organic reactions. And based on that, we have to decide the order of acidic strength, right? So if you have any doubts, mention in the comment box so that you are going to see the importance of every doubt and every question has to be solved. So to have this kind of lectures, you need to go to the coaching centers and travel along and have to pay a lot of money. But here Infinity Learn YouTube channel, we are giving you the lectures full free of cost. Take advantage of this and take these noteworthy tricky points, and please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. And let us see one more question here. So moving ahead, here the compare the acidic strength of this. As I mentioned, acidic strength is directly proportional to negative inductive effect. So the negative inductive effect is directly proportional to the fluorine. So negative inductive effect is going to be fluorine is greater than chlorine. So that fluorine का negative inductive effect ज़्यादा है, chlorine का negative inductive effect कम है, and it is going to have a positive inductive effect. So that what I can say here, acidic strength 1 is less than, 2 is less than 3. And you know Ka value, 1 is less than, 2 is less than 3. What is the pKa value? 1 is greater than, 2 is greater than 3. So in the NEET examination, you just be careful what exactly is asked and how the options are going to be tracked. So you will be giving a various option, which of the following is correct, which of the following is not correct. So each and every question is so valuable. If you do one correct, +4. If you do wrong, you are going to get -1. So you lost 5. So आने वाले के 4 mark नहीं आएगा and 1 mark will be deducted. So take care and do the best. Moving ahead, compare the acidic strength of these time alcohols. You know, alcohols are going to be acidic. How do I say that? When alcohol is there, this bond can be broken to give rise RO minus and H plus. And it all depends on R. So acidic strength again, negative inductive effect, and acidic strength again, positive inductive effect. Now let me talk about this. Acidic strength, it is going to have positive inductive effect. It is going to have positive inductive effect, more positive inductive effect. Due to 3F3 fluorines is going to have negative inductive effect. So I would say the acidic strength is going to be 3 is more than 1 is more than 2. That's very important. 3 is more than 1 is more than 2. Even you can just go ahead with your pKa values, Ka values and acidic strength values and the pH of the given concentration and all. So most of the questions will be tackled at the range of acidic and Ka value and pKa value. So moving ahead, compare the acidic strength of this. So you have given various parameters to say this is the carboxylic acid and this is the benzene. So the correct order of acidic strength, the carbon atom is an sp3 carbon, it is an sp2 carbon and it is sp2 carbon, and you know this is sp2 carbon into 6 carbons are there. So it is going to be more acidic as compared to this. You understand? Because this is the carbon sp2 ka hai, sp2 ka hai, compare. Collection of sp2 will have a strong acidic strength. So if you see positive inductive effect, so electron is pushed here, and negative inductive effect of the alkene sp2 ka hai, electron is pulled here, and it is sp, it is going to pull more greater than this because electronegativity of sp is greater than electronegativity of sp2. But here हर कार्बन एटम का sp2 है ना, so eventually the overall effect of this sp2 will be more because 6 carbon atoms are there, so the pull is going to be more. So this is nothing but negative inductive effect, and this is negative inductive effect and negative inductive effect. Observe the inductive effect. So as this is pulling more effectively, 4 is going to be the more effective as compared to 3 than 2 than 1. So this is how we have to be mentally stable and work on the given example to give the exact answer. So I am discussing the question at the level of NEET, and I am making you to explain and how to attack this kind of question when it comes to the NEET examination. So I want to say, based on this negative I effect series, the order of acidic strength 4 is greater than, 3 is greater than, 2 is greater than, and 1. So 4, 3, 2, 1. But here students will confuse with 4 and 3. That is a trap that you can go into the NEET examination. Never and ever go into the trap, and always focus on the questions, and the actual concept clarity is required. For that reason, we are giving you one short program for every important topic for the NEET examination. Mind it, please attend these lectures without any delay and open up, and you can have any doubts, you just mention in the chat box or the comment box so that we can have a discussion about this. Okay, take a pen and paper, write all the noteworthy points that I am going to explain, all the amazing explanation with this sure short NEET probable questions. And also we have compare the acidic strength of these. So take a minute and you solve it, and I want to know in the comment box how you solve this question. Waiting for your answer. Dear children, here it is a positive inductive effect. Whenever you see everything is common now, you take the common out. This is a common, this is a common, and this is a common, and this is a common. Now you see that this chlorine is having inductive effect. Chlorine is there on the first carbon. Second carbon, I would like to say, as respect to the first carbon, this is going to be the second carbon. Here the chlorine is present on the first carbon, second carbon, third carbon, and the chlorine is present on the first carbon, second carbon, third carbon, and fourth carbon. And I already mentioned distance dependent. Inductive effect is distance dependent. So as distance increases, inductive effect decreases. So I want to say inductive effect inversely proportional to distance. Inductive effect is inversely proportional to distance. So that here negative inductive effect is there, negative inductive effect is there, negative inductive effect is there. Here exactly positive inductive effect is there. So 1 is supposed to be the least. So here it is given 1 is supposed to be the least positive inductive effect का हिसाब से, and it is going to have first carbon and second carbon का inductive effect बहुत ज़्यादा रहेगा. Pull will be more, and inductive effect will be first and third carbon atom. Pull will be less, and first, second, third, fourth pull will be very less. So the actual order is going to be 2, 3, 4 and 1. So 1 is the least and 2 is the most. Why? Because more inductive effect is seen. So hope you understand this. So you need to understand the acidic strength is directly proportional to inductive effect, negative inductive effect. So negative inductive effect is going to be directly proportional to that 1 by distance. Okay, so inductive effect is distance operated. And also I want to say a basic strength. What is a base? Amines are the base. You see, it is ammonia, lone pair of electron, primary amine, secondary amine, and as a tertiary amine. Okay, so let it be anything. You talk about the amine because of this electron H plus acceptor. So it is a base, so that you are going to get RNH3 plus. It is a conjugate acid. So basic strength is directly proportional to the stability of conjugate acid. As basic strength increases, and you can say Kb value increases, pKb value decreases. In general, I want to say alkyl amine is more basic than ammonia, is more basic than aniline, or otherwise you can say Not only this inductive effect, but also resonance can make you to say which is more basic or which is less basic. So we will take a couple of examples where only the inductive effect is there, because we are still in the inductive effect order. I want to say the basic strength is directly proportional to availability of the electron pair on the nitrogen. So in general, I would say, so the amines, primary, secondary, tertiary amines are there. So if you don't use any aqueous solvent, the amines basic strength is always tertiary is greater than secondary is greater than primary. But also you can see the basic strength. Ammonia H plus gives rise ammonium conjugate acids. Primary amine H plus gives rise its conjugate acid. Secondary amine is going to take H plus gives rise its conjugate acid. Tertiary amine is going to give rise its conjugate acid. So what are the factors that stabilize these cations or conjugate acids? Various factors you study. It could be a solvation effect or it could be hydrogen bonding. So मैं बोलना चाहता हूँ क्या, when you work with inductive effect, सिर्फ inductive effect नहीं चलता, rather all kinds of applications has to be done on the one molecule in various aspects, multidimensional. The order of basic strength, tertiary amine is greater than, secondary amine is greater than, primary amine is greater than ammonia if it is given in the non-aqueous, in the vapor phase. That's very, very important. No other effects can work except inductive effect. But very important, this order is only true in the case of gaseous phase or in the pure liquid phase of the amines. But whereas in the aqueous phase kya hoga? In the aqueous phase, the factors that will contribute to the stability of this conjugate acid is both inductive effect ke saath, you are going to see solvation through hydrogen bonding. These effects will work. Therefore, I would like to say it's very important to determine the basic strength of amines in the aqueous phase, especially most of the cases. NEET examination loves exceptions. Wherever twists and turns are there, you are going to see the actual phenomenal change there itself. So NEET questionnaire is always focused on the aqueous phase. So what happened? We have to consider both inductive effect, solvation effect and steric hindrance alag deke karna. So you don't have to worry. I am going to give you the order that can help you. So the order of basic strength, therefore experimental Kb वैल्यू का हिसाब से आपका मिलेगा. मिथाइल ग्रुप होगा तो 10 secondary is greater than primary is greater than tertiary is greater than ammonia. If it is a ethyl group, it is going to be secondary is greater than tertiary is greater than primary, and you see the variation comes here. That's very important. And this is the order given in the NCERT. As I mentioned, NCERT is everything. Everybody take a screenshot of this. So based on this, definitely you are going to get a question from the NEET examination. Moving ahead, resonance. Talking about the resonance. And before going for the resonance, we can just also see the order of stability of carbocation and carbanion. Within the resonance we will discuss, and hyperconjugation effects also can be seen there. What is a resonance? So resonance is a phenomena. While you can see when you want to write a structure, all the properties cannot be explained by using the structure. So that you need to propose one more structure. Is that explaining in every property? May or may not. So in order to explain all the properties of the molecule, you have to write so many possible structures. But none of the structures is going to explain the total properties. So actual molecule exists as the hybrid of all the structures you proposed, and that is called a resonance hybrid, and you proposed structures is called as resonating structures, and resonance structures or canonical structures or contribution structures. And is that resonance is actually existing? No, it's not actually existing. It's a hypothetical phenomena. So मेरा बचपन में मैं क्या सोच रहे थे, बेंजीन ऐसा लिखना का. Yes, so it is the benzene. So to explain the properties of the benzene, this is one structure and this is another structure. मैं क्या सोच रहा था, एक बॉटल में बेंजीन लिक्विड देखने के बाद आपका बेंजीन, ओके, दिस इज योर बेंजीन C6H6 लेबल दिखा हुआ. So in that benzene, half of the molecules liquid present in that bottle is like this, half of the molecules are like this. ये बिल्कुल गलत बात है. So it is a hypothetical imaginary phenomena. So to explain actual properties of the benzene, ये दोनों structure रखना है. And actual कैसे रहेंगे? A molecule is going to exist like this. This is what is called as a resonance hybrid. This is what exactly is called as a resonance hybrid. In this resonance hybrid, so these two are called resonating structures, and this is called contributing structures or canonical structures. ये canonical structures लिखना कैसे? Rules for delocalization. What is the meaning of delocalization? Dislocation of the conjugated system. So let us see rule 1 to write this. Pi electrons are always transferred from one atom to another atom. So in order to show a compound which can show resonance or not, there should be a delocalization. What is the meaning of a delocalization? Delocalization is a phenomena separation by one sigma bond. So when you separate by one sigma bond, you can separate carbon, double bond, carbon, and a sigma bond and a carbon, double bond, carbon. So when you see this is a pi bond, sigma bond and a pi bond, yes, delocalization is there. And also you can say carbon, double bond, carbon and a chlorine, a lone pair of electron is there. And here this lone pair of electron and a sigma bond and a pi bond. So in this case resonance takes place. And you can say carbon, double bond, carbon and a positive charge. You can see here positive charge and sigma bond and pi bond get separated. All these cases sigma bond is one sigma bond is separated. This condition is allowing you to talk about the delocalization and gateway to say it is a resonance. Now you can see here carbon, double bond, carbon and a negative charge. It is also the same. So here is also resonance is possible. So negative charge sigma bond possible and a positive pi bond. Now dear children, everybody says resonance means you say putting the arrow mark here and there and write one more structure. No. It shouldn't be like that. That's the reason I want to say rules. There are certain rules to say resonance. So once you are very good at these rules, now you will be confident in writing resonance. So that's the reason why I always focus you to follow this resonance. The pi electrons are always transferred from one atom to another. So one atom to another. My question is, what is the atom? What is the another atom? Always during the resonance, electrons try to move from more electron density to less electron density. कहाँ से कहाँ तक जाना? Negative charge, lone pair, pi bond and odd electron and positive charge is going to be the least. So this is the order of the electronic density. Always during a resonance, electron move from high electron density to low electron density. So let's see here rule 2. Electrons of an atom, negative charge or a lone pair is always transferred to make a pi bond. And also rule 3, electrons flow from higher density to lower density, higher density to lower density. So if you take this example, electron का direction कैसे देखना? You can see lone pair, it goes like this. So the direction of the arrow head can tell you, and you can write the possible further structures for that. And you can see the conjugation. Coming to the point here, what is the meaning of conjugation? Separation one sigma bond I already shown. So if this is the structure, you can say CH2 double bond, CH single bond, CH double bond, CH2. So planarity is the essential condition. Planarity is the essential condition, and conjugation should be there. All the carbon atoms are sp2, so that planarity is seen. Now you can see this is a sp2 unhybrid pure p orbitals will be there. So far you can see a pi bond here, a pi bond here, a pi bond here, a pi bond here. So the pi bonds are perpendicular to the sigma bond here, so that there is a pi bond. Now there is another situation with the same structure. We can see CH2, CH and CH and CH2, and you can see the same orbital structures, you are going to see a bond between here and here also. So that is how it is happening. So this is what is called as a delocalization. In this delocalization, this structure and this structure is written in the Lewis pathway. So CH2 double bond CH and CH double bond CH2. So it can be written with another structure CH2, CH double bond CH and CH2. It could be negative and here could be positive. Or also you can write another structure like this, CH2, CH, CH and CH2. It could be a positive structure, it could be a negative structure. So there is a possibility of this writing all these structures is called as delocalization. So that all carbon bonds are same here. All will have the same bonding nature and everything. So these are the various structures I just want to show you. And conjugated systems. Conjugated systems here, now we know that resonance, how it is takes place, whether it is taking with the all the molecules or not. Let us say, always remember noteworthy point here is a noteworthy point. Conjugation takes place when the p orbitals of the same symmetry are present. So there are various types of conjugations are present here. You can see pi alternate pi bond. Here it is say it is a pi bond, sigma bond, a pi bond, a sigma bond and a pi bond and a sigma bond. So pi bonds are separated by sigma bonds. Example benzene. And also you can see pi bond, sigma bond, pi bond, sigma bond, pi bond. Resonance is possible here. I want to talk about this one. Pi bond, sigma bond and a pi bond. Resonance do not takes place here. Resonance takes place here. Because these two pi bonds are separated by two sigma bonds. Resonance is not taking place here. And also you see pi alternative positive. So pi bond, sigma bond alternative positive. So always electron move from the high electron density to low electron density, so that you are going to get polarized this one and you are going to get a structure this. So this structure is an imaginary structure transformed from 1 to 3. 2 actually doesn't exist. You know, allyl carbocation. So this allyl carbocation can give you a lot of impact on these resonating structures. And also you can say this is also allyl carbocation, and the negative allyl anion, the negative charge is given to the pi bond. So this is a negative charge, sigma bond, and it is a pi bond. So that what will happen? Negative charge will come and pi bond is kicked out. If it is a carbocation, you see CH2 double bond CH and CH2 positive. It is a cation. Electron move in this direction. So that you are going to see the various resonating structures like this. CH2, CH double bond CH2. it is going to be positive. So it is cation. Cation means pi bond is coming to the carbon, positive charge. It is an anion, and negative charge is coming towards the positive charge. So this is called allyl carbocation. And this is allyl carbanion. This is allyl carbanion. Of course, both allyl carbocation, allyl carbanion, both are going to be stable due to resonance. Moving ahead, the pi alternate odd electron. This is a free electron, so it is a free radical. Of course, this is allyl free radical. So allyl free radicals also stable. And this allyl free radical, whenever free radical comes, there is homolysis takes place. You can take here, this is your allyl free radical again, and it is going to give you various structures like this. So this is allyl free radical. Now this is going to be very important, pi and alternative lone pairs. So here it is a pi bond, sigma bond, lone pair of electron. Always lone pair of electron has more density than the pi bond, so that the electron pair is moved from here to here, so that you are going to get a polarized structure like this. And here is also again is coming back to this. So there is a resonance in cases similar to pi, alternative negative charge of the lone pair and a negative charge are treated similarly. Similarly, you can see oxygen and a pi bond is there. Now you can see this is the same scenario. So like that, various resonating structures you are writing, and it is coming back to its original structure like this. And ये दोनों में कौन सा अच्छा stable होगा, that we have to discuss it now. So neutral structure is always more stable than the positive structure, right? So moving ahead here, drawing the resonating structures in the right way. Everybody write the resonating structures according to your basic knowledge. And resonating structures means you feel that it is simply writing the arrow marks, but the resonance is not that. Resonance has its own systematic way. So basic thing, condition for resonance, the structure should be planar, then only resonance takes place. If the planarity is missing, resonance do not take place. And there should be a conjugation. Conjugation means the separation by one sigma bond is called conjugation, and in this conjugation always electron move from the higher electron density to lower electron density, and only electrons should move but not the atoms. So these are the basic synopsis, and you can do the resonating structures like this. My dear children, you look at this CH2, CH, CH, CH2 positive charge. Yes, I will check whether it can show resonance or not. Pi, sigma positive charge. Yes, of course it is eligible to show. So you are going to say you can write its structure simply by taking the electrons in this way, because positive charge is going to take care of this. So you are going to see CH2 positive and CH double bond CH double bond CH2. So like that, without changing the position of the atoms, you can write the resonating structures. And you can also say, so drawing the right way, you can say this is the one carbanion. So the previous structure only I am writing here? No, you check carefully, that is a positive charge. है क्या ना? अभी तो negative charge का है. So you take this negative charge. When you take this negative charge, it is going to participate in the resonance in this way. So the reverse way. Always electron move from the higher electron density to lower electron density, ताकि इसका structure आएगा CH2 negative and CH double bond CH and CH double bond CH2. This is the structure you can write. So both are equivalent structure, you can do it best. Rules for resonating, validity of Lewis structures. Rules for writing resonance. So bachcho, all the Lewis structure must come from Lewis octet rule. Every atom supposed to participate in octet rule. If carbocation is there, carbon free radical is there, octet is not followed. As I mentioned, carbon cation 6 electrons and carbon free radical 6 electrons are there. And example, carbon, nitrogen, oxygen can't be pentavalent. You can say CH2 double bond CH3. Yes, you say it is a positive pi bond, sigma bond and a positive charge. Yes, it is eligible for resonance. You want to move the electron here, you are going to get this. Now, this is impossible structure. So far in the JEE mains examination, even for the NEET examination, nitrogen cannot be pentavalent. Based on the trick, you have been given a couple of questions so that it is not possible. The reason is nitrogen is forming 5 bonds in that structure, so that it is not possible. And you can see here the positive of the position of atoms in all resonating structures must be the same, only the electron can move from one place to another place. Now let us say example CH3CO CH3, CH3OH and CH2. It is not resonance. Rather it is a tautomerism. I don't say it won't happen, it will happen, but it is not the resonance. Hydrogen atom is wandering from here to here. You can say hydrogen atom is moved here, pi bond is shifted. This is tautomerism, not resonance. Tautomerism is a real phenomena and resonance is a hypothetical phenomena. So that this will not occur as a resonance, but it occur as a tautomerism. Right now we are talking about the resonance, so that I would say it is not resonance. And moving ahead, all the resonating structure must have the same number of electron pairs. चाहिए electron pair, bond pair हो सकता है, lone pair हो सकता. So let's see here. This is a structure. How many sigma bonds are there? How many pi bonds are there? Total lone pairs are there. You can see this structure has 9 sigma bonds and pi bonds to lone pair 0. Sum is going to be 11. Total number of electron pairs should be constant, and in that sigma bond should be constant, and pi bonds are 1, lone pairs are 1, sum is going to be 11. While you can say this is sigma bonds are 9 and lone pair 1, sum is going to be 11 and pi bond is 1. So these 3 are possible resonating structures. This is a very important interpretation for the resonance. Coming to the rules of stabilization for the resonating structures. So here, order of stability of resonating structures, I want to give you with a proper explanation here. You can say rule number 1, I want to say resonating structures with greater number of covalent bonds, that is more number of pi bonds in it, are going to be more stable as compared to the resonating structures with less number of pi bonds. You can see this is an example where you are going to see pi bonds are 2. In this only one pi bond is there. In this pi bonds are 0. Here one pi bond is there, but charge separation is more. So the order of stability in a neutral structure is always more stable as compared to the charged structure. So that I want to give you the first one is more stable, then 2 and 4 are going to be more stable than 3. So you will be having a doubt which is more stable than this. We are going to see subsequent rules for this. Talking about here one more rule 2, resonating structures with similar charges on adjacent atoms are insignificant. I want to say here this is a positive charge and this is a positive charge. This is insignificant. जैसे structures नहीं exist कर सकते. Now this is also not stable. I just want to say this is only the neutral structure. Of course, charge separation is unstable, charge delocalization is more stable, and whenever 2 similar charges are there on the side by side carbon atoms, let it be positive charge, let it be negative charge, due to super repulsion you are going to be unstable. Moving ahead here, rule number 3, structure with a positive charge on multi-bonded electronegative atoms are important nahi hoga. So you can say a positive charge. So positive charge on multi-bonded things. You can say positive charge on carbon and positive charge on oxygen. So you can say this is more stable and this is less stable, because here positive charge is seen, and here is a contrast. I am not going to agree with this because it is octet nahi hoga, so that it is not correct. So moving ahead, rule number 4, resonance stabilization is greatest when there is at least 2 equivalent structures. So this kind of resonance gives you super stability. So benzene and this structure is also benzene and similar structures. Actually, I wanted to give you the structure like this, and it is going to give you the resonance hybrid like this. Carboxylate ion. This carboxylate ion can have equivalent resonating structure. So it is going to be super stable. Allyl carbocation is also going to be super stable. So the examples we can include, whenever similar resonating structures are coming, it is going to be very, very stable. Moving ahead here, rule 5, charge separation and charge delocalization. What is the meaning of this charge separation? When a neutral molecule unnecessarily getting charged, that is called charge separation. When a already charged molecule due to resonance charge is moving here and there is called as a charge delocalization. So charge separation is super unstable, charge delocalization is super stable. You can see this is called charge separation, unstable. This is also charge separation, unstable, but it is already charged, now it become a charge, is moving here and there. This is called charge delocalization, is going to be more stable. Understand? Moving ahead, which of the following structure is more stable? Somebody in the chat box, you can give the answer. So it is a carbon with a positive charge. Whenever carbon with a positive charge, you are going to get 6 electrons. Whenever carbon with a negative charge, it is going to be octet. I want to say structure with octet is always stable as compared to structure with no octet. I just want to say this is going to be 2 is going to be more stable than 1. Similarly here, I just want to give the order of stability of the resonating structures. 2 similar charges, never and ever stable, and this can be stable and this can be stable and this can also be stable. One is going to be more stable. Why? It is a neutral structure. So 1 is the most stable and 3 is the least stable. Based on that, you can say these opposite charges and more charge separation is there. I want to say 1 is more stable than here. 5 is more stable than 2 is more stable than 4 is more stable than 3. So that is the order for this particular given structures. So here, give the order of stability of the following resonating structures. Again, you can just see the number of multiple bonds. So pi bonds are 2, pi bonds are 2, pi bonds are 2. And here carbon with a negative charge, oxygen with a negative charge, and nitrogen with a negative charge. So that what I want to say here, 1 is more stable than 3 is more stable than 2. Why? Because negative charge on more electronegative atom is stable. So electronegativity of oxygen is greater than nitrogen is greater than carbon. Okay. Moving ahead, mesomeric effect. So far we have seen the resonance. So what is a mesomeric effect? The effect which triggers this resonance is called as a mesomeric effect. So I want to say here, let us say this is a conjugated system. When this conjugated system OH is given, so the lone pair of electrons present in the oxygen is going to trigger the resonance that is taking place on the benzene, so that you are going to see its polar structure. Its polar structure, it is going to be NH2. Okay, so it is going to be further given to its resonating structure like this. So this is what is called as a positive mesomeric effect. This is a thing that is happening to further resonance. So, you have two types of orders, positive mesomeric effect, negative mesomeric effect. So, you are going to have positive resonance effect or negative resonance effect, or positive mesomeric effect or negative mesomeric effect. So, what makes this difference between the positive mesomeric effect or negative mesomeric effect? I wanted to show you here. Let us look at this. NH2, the lone pair of electron that is given to the benzene. So, that this effect is giving electrons to the benzene. So, that this is what is called as a positive resonance effect or positive mesomeric effect. As a result of this, what will happen? It is going to give you the resonating structure like this, NH2. And this effect gives the negative charge on the benzene ring. So, let me give you its further resonating structures. Negative NH2, and it is going to give you further resonating structures. It is going to be the negative, it will be like this. So, as a result of this positive mesomeric effect, you are going to get the hybrid of this NH2 positive charge, negative charge on the benzene ring is going to be accumulated, and this is the order of the positive mesomeric effect or positive resonance effect. Now, negative resonance effect, let me write about the negative resonance effect. If you talk about this benzaldehyde, as a result of this benzaldehyde, here you are going to see the electrons are given back to the benzene. So, that is what is called as a negative mesomeric effect. As a result of this, you are going to positive charge over here, double bond NH2, and you are going to see like this. Okay. So, this is going to be C double bond O. So, as a result of this, the resonance hybrid for this is going to be COH. Positive charge is accumulated on these ortho and para positions, right? So, that whenever positive mesomeric effect is there, ring is negatively charged and it is going to be more reactive, and it is going to be ortho and para director in the electrophilic aromatic substitution reactions, whereas in the negative mesomeric effect vice versa takes place. The ring gets positive charged. So, as a result of ring is getting positive charged, it is going to be ortho and para positions are getting positive charge, so that it is going to be meta director in the electrophilic aromatic substitution reaction, so that the ring is going to be deactivated. You can say in the negative mesomeric effect, in the positive mesomeric effect, ring is getting activated. So, let us see the applications of these various. Now, this is the slide can give you the order of the resonating structures and resonance or the mesomeric effect. It is misleading in the student's mind about this inductive effect as well. If you see the contrast to this inductive effect, A order alag hoga, A order se. So, you can say the other things. So, applications of resonance effect. Acha baat hai. Going good. Nice. Let's talk about applications of resonance effect. So, arrange the following in order of decreasing acidic strength. You know, acidic strength, bachcho, acidic strength is directly proportional to negative mesomeric effect and inversely proportional to positive mesomeric effect. And you can see this is your negative mesomeric effect and negative inductive effect, and positive inductive effect, and it is going to be negative inductive effect and a positive mesomeric effect. You consider negative inductive effect, a positive mesomeric effect. Here, I want to say, whenever halogens are there, my dear students, You don't consider mesomeric effect, you consider inductive effect, because they are weak mesomeric effect and strong inductive effect. Whenever mesomeric effect and inductive effect is there, consider mesomeric effect. So, inductive effect and mesomeric effect both are same here, both are in same direction. So that among them it is going to be 2 is more than, 4 is more than, 1 is more than, no effect, and here 3 and 4, in that positive mesomeric effect is decreasing the acidic strength than 3. So, this is the order. Logically you can write. If you have any doubts, please let me know in the comment box. And we can write not only phenols, but also you can go ahead with other things, carboxylic acids. Arrange the following in decreasing order of pKb in the conjugate basis. So, pKb value decreases, mean to say stability increases. So, let us directly write the acidic strength for that. So, carboxylic acid, positive mesomeric effect, negative inductive effect. Aldehyde, negative inductive effect, negative mesomeric effect. When it comes to positive mesomeric and negative inductive effect, you don't consider this, you consider क्योंकि ये halogen है. And both are very good, no worries. And in this, you have to consider this. You don't consider this. So, I want to take 3 is more acidic than, 4 is more acidic than, 1 is more acidic than 2. So, these are all the important aspects that are required. Any doubt? Bacho. So, the order of acidity of the following compound. The general order of acidic nature of the compounds is going to be carboxylic acid. Okay. The answer is going to be, you just see the general order for this carboxylic compound is RSO3H more acidic than squaric acid is going to be more acidic than, and you are going to get RCOOH is more acidic than, H2CO3 is more acidic than, phenol is more acidic than, methyl alcohol is more acidic than, water is more acidic than, alcohol is more acidic than, okay, alkyne. So, alkyne, terminal alkyne you can say. So, based on this generic acidic nature of the total organic compounds, you can say that. So, carboxylic acid is more acidic than water, than alcohol, and acetylene, it is an alkyne. So, based on this, I would like to say option D is the correct answer for this question. Now, moving ahead, hyperconjugation. Hyperconjugation is going to be a very impactful story for alkene stability, carbon free radical stability, okay, and carbocation stability. So, let us talk about hyperconjugation. So, the hyperconjugation, this is otherwise called Baker-Nathan effect or sigma pi conjugation. You can see other names for the hyperconjugation, no bond resonance, Baker-Nathan effect, or sigma and pi resonance. Okay, you have the delocalization of sigma electrons with vacant p orbitals of anti-bonding pi star orbital. What is that? I am going to show you the picture over here. And stability increases due to delocalization of sigma and pi electrons during this process. So, this is what is called as a hyperconjugation. In this hyperconjugation, you can see, so condition for showing hyperconjugation, हर बार hyperconjugation होगा ही नहीं होगा? Yes, it is a very important noteworthy point. You see, these are the conditions: presence of at least one alpha hydrogen at a saturated carbon with respect to alkene, benzene, carbocation and a free radical. I mean to say carbon with a positive charge. So this is what is called as alpha carbon. ये जैसे जो alpha carbon है इसका हाइड्रोजन होना है, so this is called alpha hydrogen. So presence of at least one alpha hydrogen is very important for this. So there is a push in the system. The system is going to participate in the hyperconjugation. You can see the carbon atom directly bonded to an atom or a group is functional group is called alpha carbon. You can see कार्बन टू कार्बन डबल बॉन्ड, ये कार्बन डबल बॉन्ड के हिसाब से ये अल्फा कार्बन होगा, ओके, एंड ये भी अल्फा कार्बन होगा, ओके, एंड ये भी अल्फा कार्बन होगा, ये भी अल्फा कार्बन होगा. लाइक दैट यू कैन राइट देयर आर 12 अल्फा हाइड्रोजन्स आर प्रेजेंट in this given structure and total 4 alpha कार्बन्स है. सो हर कार्बन का 3 हाइड्रोजन मिलके 4 into 3 is going to be 12 alpha hydrogens are seen. Now you can see here in this 12 alpha hydrogens are there. So identification of alpha hydrogen is the key point in deciding hyperconjugation. Okay, जितना number alpha hydrogens होगा उतना ही hyperconjugation structures आ सकता, so that stability is going to be increased in the more conditions. Okay, let us see here. So hyperconjugation. So observed mainly in carbocations, carbon free radicals and the double bond. I want to say it is an alkene. It is said to be an alkene, right? And you can say here what is a hyperconjugation structure. So this is a carbon now. So in this carbon you can see, bacho, this bond is going to be shifted here, so that ये carbon positive, hydrogen positive होगा, ये hydrogen positive होगा, ठीक है, and this bond become a pi bond. So this hydrogen positive is going to give a resonating structure. Bacho, here there is no bond, but you can still expect a resonance, so that you are going to get a place. Okay, it is a reversible arrow mark. Okay, and this bond is shifted from here to here, so that you are going to see a structure H plus. So again you are going to get this structure. So in hyperconjugative structures there is no covalent bond between carbon to one of the hydrogens. So there is no bond. There is no bond. So hyperconjugation is also called as no bond resonance. अरे एक चीज़ मैं आपको बताना चाहता हूँ. If music is on, so a bachcho, so he is dancing, so you can say he is active kid. Even music is not on, the kid is dancing. Or you can say a bachcha hyperactive hai. So if bonding is there, it is participating in resonance, so it is a normal resonance. लेकिन bond भी नहीं है, but participating in resonance, that is called as hyper resonance or hyperconjugation. It is first observed by Baker and Nathan, so it is given as a Baker-Nathan effect. So moving ahead, so if you see this is the carbon, positive charge is in sp2 hybridization. A sp2 hybridization structure का हिसाब से एक unhybridized pure p orbital is there. Unhybridized pure p orbital. This is unhybrid pure p orbital, and there is a methyl group. So here CH3 CH2 plus का structure दिखाना चाहता हूँ, carbon, and this is hydrogen. This is a sigma bond, and this sigma bond is going to participate in the formation of pi bond in the anti-bonding pi star of this p orbital. That is very, very important. So this phenomena you can say it is a hyperconjugation. Okay, and moving ahead, this hyperconjugation, various structures are given in the carbon free radical as well. Now you can see these are the structures now. So this structure I just want to show you. There is a homolysis, always gives a homolysis, and again double bond and a double bond, you are going to get this one. Okay, and you are going to see this is a single bond actually. Okay, and it gives various bonds like this. Okay, now you can see this is the one, this is the one is coming in between, so a bond is formed. Like that hyperconjugation is seen in the carbon free radical as well. And moving ahead here with This is a toluene. This is a toluene. In this toluene, you are going to see a Baker-Nathan effect. So, this is a bond is coming like this, so that you got a negative charge over here. This lone pair of electron, again it is participating. So, because of this hyperconjugation, you are going to get ring is activated. Toluene shows positive inductive effect as well as a positive hyperconjugation. There is a negative hyperconjugation. Similarly, like this, 6 more structures can be drawn using this one here, here, here. So, I want to say there is a phenomena called as a negative hyperconjugation. What is this? If you see trichlorotoluene, this is a trichlorotoluene Cl, and it is going to be Cl. And it gives you chlorine being highly electronegative, it gives you the structures like this. Are you getting or not? So, this is what is called reverse hyperconjugation, and this is what is called as a positive hyperconjugation. So, hyperconjugation, here stability of the carbocation, free radicals and alkenes is directly proportional to number of hyperconjugation structures, and which is actually directly proportional to number of alpha hydrogens, and that gives you direct impact on direct uses of hyperconjugation. You can simply use it for your JEE or NEET examination. So, deuterium can also show hyperconjugation, but this deuterium shows a less hyperconjugation tendency because more bond energy. And also CD bond has a stronger than CH bond. Hyperconjugation of CD bond is weaker than CH bond, and this could be assertion in the JEE examination, or this could be the reason for this. And reason is the correct explanation of assertion. So, moving ahead, so comparisons of electronic effect. This is a super important point. So, what is this? You have inductive effect, you have mesomeric effect, you have hyperconjugation. So, what is the actual order you need to follow? I already given you that. So, comparison of electronic effect. So, a hydrogen bond is super effective than steric effect, then aromatic effect, then you can write the resonance or mesomeric effect, then hyperconjugation, then inductive effect. So, these are the various effects that I want to show you, and in the same way inductive effect, mesomeric effect, hyperconjugation effect, just have a short recapture about that. So, inductive effect is found in saturated sp3 hybrid carbons, and you can say only sigma bond operated, and you can say it is a distance dependent. Whenever mesomeric effect involves a complete shifting of the electron pair across the conjugation, and it is not distance dependent. And hyperconjugation is found in carbocation, carbon free radical and alkene. So, among this, mesomeric effect is more stronger than hyperconjugation and inductive effect. So, moving ahead, dear children, inductive effect involves a partial shifting of electrons. Mesomeric effect is found in unsaturated compounds and conjugated systems, and hyperconjugation involves partial shifting of sigma electron towards the pi, and there is no bond but resonance can happen. And you see, inductive effect, the electron pair is slightly moved more towards the electronegative, okay, and in the mesomeric effect, electron pair is completely shifted in the conjugated system, while the hyperconjugation, the electron pair is partially transferred across these alpha hydrogens, and you need to know the impact of this. So, that I want to say generally inductive effect distance dependent, mesomeric effect distance independent, and hyperconjugation distance independent. So, in this case you have Mesomeric effect is more effective as compared to the resonance, is compared to the hyperconjugation and inductive effect. So, generally in case of halogens, positive inductive effect dominates as compared to the positive mesomeric effect. In the case of halogens, negative inductive effect dominates in as compared to the positive mesomeric effect. Okay, and also applications of hyperconjugation effect. You have three major applications: stability of intermediates, and explains the heat of hydrogenation, especially for the alkenes and as well as the bond length. So, let us see the stability of the intermediates. Stability of carbocation is directly proportional to number of alpha hydrogens. When you talk about this tertiary carbocation, we always know this tertiary carbocation is more stable than secondary carbocation, is more stable than primary carbocation. So, tertiary isme 3 alpha, 3 alpha and 3 alpha, 2 alpha, and here it is going to be 1 alpha, then there is no alpha. So, you can also say inductive effect as well as hyperconjugation is same, and दोनों का हिसाब से tertiary is more stable than secondary is more stable than primary methyl carbocation. Moving ahead, dear students, free radicals भी ऐसे wherever you see, my dear children, free radical stability just follows as carbocation stability. That is a thumb rule you have to follow all the way. And talking about this tertiary, secondary and primary, and methyl free radical is going to be the part of this reactivity and the stability. And also you can say enthalpy change that accompanies the hydrogenation of 1 mole of compound of the product. It is called as heat of hydrogenation, or CH double bond CH and R dash. When you add hydrogen in the presence of a platinum or palladium or nickel, you are going to get RCH and CH2 CH2 R dash. So, this is called as enthalpy heat of hydrogenation. This is what is the definition of heat of hydrogenation. You know one thing, heat of hydrogenation, delta H hydrogenation inversely proportional to stability of alkene. Stability of alkene. The alkene which is less stable is going to be more heat of hydrogenation. So, that I want to show you here with various examples. So, this is the alkene H2 nickel, you are going to get minus 60. This is the alkene, you got it is plus 28. This is the alkene, you got it is plus 30. So, I want to say here in this case, for rule number 1, heat of hydrogenation is directly proportional to number of double bonds first of all. If the double bond number is the same, the one which is least stable will have the highest heat of hydrogenation. Please don't memorize these values. These values are proposed to you, shown and displayed to you to understand how the heat of hydrogenation can impact. So, this heat of hydrogenation data tells us stability of alkene in lesser heat of hydrogenation. So, here it is 2 double bonds 60 and it is 1 double bond terminal, and it is hyperconjugation is there here, more hyperconjugation is there, less heat of hydrogenation is seen. So, here it is about the heat of hydrogenation here. So, and I want to show you heat of hydrogenation is directly proportional to number of pi bonds, rule number 1. If number of pi bonds are same, heat of hydrogenation inversely proportional to stability of alkenes. So, moving ahead, I will give you the heat of hydrogenation. So, before going for that, I just want to give you CH3, C double bond, CH3 and CH3 and CH3, CH3, CH3 and CH3, CH3, C double bond, CH2, CH3 and CH3, CH3 and CH3, 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 CH double bond, CH2. So among these, you can have a look at this 12 alpha hydrogens are there, 9 alpha hydrogens are there, 6 alpha hydrogens are there, 6 alpha hydrogens are 6 alpha hydrogens are there, 3 alpha hydrogens are there. Among this, stability, I want to say this is more stable than this and these are more stable than this. Bacho, you can say this is a cis isomer and this is a trans isomer. So, cis isomer is less stable as compared to the trans isomer. But this is called isobutylene. This isobutylene is always more stable than transbutene because of this hyperconjugation structures gives you the primary carbanion which makes it more stable. That's very important. Talking about electromeric effect. So, it involves complete shifting of the pi electrons. It is absolutely a temporary effect and there are two types of electromeric effect. So, temporary effect which is observed only in the presence of an attacking reagent. As long as an attacking reagent is there, it is going to involve in this electromeric effect. So, I want to show you the type of electromeric effects, positive electromeric effect and negative electromeric effect. Let us talk about the positive electromeric effect. Positive electromeric effect. The pi electrons of the multiple bonds are transferred to atom which the reagents get attached. So, here this is a reagent, okay, it is a reversible. Pi bond is shifted towards the carbon atom where the reagent is attached. This is what is called as a positive electromeric effect. Now, negative electromeric effect. Now, this negative electromeric effect, this is the reagent is attacking to a carbon, but the pi bond is shifted away from this so that it is going to have a negative electromeric effect. So, I want to say positive electromeric effect, a positive charge is attacked in the negative electromeric effect and negative charge reagent is being attacked. So, here moving ahead, a cyclic conjugated saturated molecule or ion that is stabilized by pi electron or the delocalization is called as aromaticity. Of course, it is going to be a super important topic. How do you say compound to be aromatic? Yes, the compound can be aromatic. Aroma means a characteristic smell. So, aroma means a characteristic odor. So, aromatic compounds will have a characteristic smell. So, aromatic compounds are said to be aromatic here. They should fulfill certain points. I want to discuss about these certain points here. Compounds, cyclic compounds are classified here, aromatic, anti-aromatic compounds and non-aromatic compounds. So, what is this? Look at this, a compound said to be aromatic if it fulfill Hückel rule. What is the Hückel rule? So, in order to say a compound to be aromatic, a compound should be planar and fully conjugated within the ring structure and also be monocyclic system should have 4n plus 2 number of pi electrons. So, you have to solve for this n value. If the n value 0 to infinity, it is going to be aromatic. So, what is applications of electronic effects? We already seen this. In this aromatic system, you can say compound to be aromatic. In order to say compound to be aromatic, I want to say there are certain points. Compound should be cyclic and planar, and the compound should have complete delocalization. It should obey 4n plus 2 number of pi electrons. If a compound is accepting this point and this point and this point, the compound is said to be aromatic. If the compound is accepting this point and unfortunately Hückel rule is not followed, it is said to be anti-aromatic. If the compound is missing any one of these 2 points, there is no sense of doing third point. That compound is said to be non-aromatic. Now, the order of stability, aromatic compounds are more stable as compared to non-aromatic compounds, and anti-aromatic compounds are super unstable. Say an example here. Cyclopentadienyl anion is more stable than cyclopentadiene is more stable than cyclopentadienyl cation. So, this is aromatic, non-aromatic and anti-aromatic, like that. So, let us see the total applications of the electronic effect. Electronic effects, it can influence bond energy, it can influence dipole moment, it can influence acidic and basic strength, and also stability of the reaction intermediates and stability of alkenes and bond length as well. So, let us quickly look at this one and each and every point over here. So, let us talk about the intermediates. You have carbocation, carbanion and carbon free radical. So, in this majorly you can see carbene, benzene, nitrene and kind of things. But this is important. Mostly you can see these intermediates in this organic reaction mechanisms. And let us talk about carbocation. Carbocation, carbon undergo sp2 hybridization so that it is going to be a planar system. And you know there is a unhybridized pure p orbital lies perpendicular to the plane of this triangle, and the bond angle is going to be 120 for this carbocation. And 6 electrons are there, and aromatic carbocations are highly stable, and all the electrons are paired, hence it is a diamagnetic in this parameter in the Lewis acid. You see, aromatic carbocations are highly stable, you can say. Trophylium carbocation, this is your trophylium carbocation, it is going to be aromatic, so that it is highly stable. And also, stability of carbocations can be explained on the basis of Mesomeric effect, resonance delocalization of charge, and hyperconjugation. It could be positive hyperconjugation and inductive effect, positive inductive effect. These are the factors that makes the carbocation more stable, and you can have trophylium carbocation is more stable due to resonance and aromaticity, and cyclopropenium carbocation is more stable because of the resonance, and triphenyl methyl carbocation is more stable due to resonance, and diphenyl methyl carbocation and benzyl carbocation, and you are going to see from here allyl carbocation and tertiary carbocation, secondary carbocation, primary carbocation and methyl carbocation. The order goes like this. And you know vinyl carbocation and phenyl carbocation, they are going to be very less stable, and of course carbocation with positive charge is unstable, and you know at the worst you can see this is unstable, this is a bridge headed carbocation. Bridge headed carbon cannot be sp2 hybridized, that is called as a Brett's rule. This is what is called as a Brett's rule. And moving ahead, Brett's rule, bicyclic molecules cannot have bridge headed carbon as sp2 hybridized. I mean to say the same structure. This is a cyclic structure and this is a bicyclic structure. If this bicyclic structure has positive charge over here, this cannot be sp2. So, such structures are never and ever stable. That is what is called as a Brett's rule. Very important for competitive examination. You are going to get such type of structures are outrightly never exist. And also moving ahead, stability of alicyclic cations. Stability of alicyclic cations. 6-membered ring is always more stable than 5-membered ring, as 4-membered ring and 3-membered ring. Steric strain. Steric strain is also very important, that is called as angle strain. Stability is inversely proportional to the steric strain. So, 3-membered ring, 4-membered ring, 5-membered ring, 6-membered ring. 6-membered ring is going to be more stable in the most of the cases. And also, you can say points to remember order of stability: benzyl carbocation, cyclopropyl methyl carbocation. So this is super stable. The most stable carbocation in the total organic chemistry is going to be cyclomethyl propyl carbocation due to dancing resonance. What is this dancing resonance? Look at this structure. You are going to have this positive charge and it is going to give you positive charge and it goes like this. This is what is called as a dancing resonance. And also types of reactions. Organic chemistry reactions are various types and it is given as substitution reaction, addition reaction, elimination reaction and rearrangement reaction. Let us see in detail and broad picture about these reactions here. And in the substitution reactions, you see here CH4, one hydrogen from the methane is replaced by chlorine. So, you are going to get a methyl chloride. So, one hydrogen is replaced with one chlorine. So, it is called as substitution reaction. One atom or a group is replaced with an atom, another atom or a group is called as a substitution reaction. And addition reaction, in order to have addition reaction, you need a pi bond. So, carbon to carbon double bond is there. If hydrogen is being added, so alkene become alkane. So, this is called addition reaction. Bacho, here you can see the previous one. If this substitution is initiated by electrophilic substitution reaction, nucleophilic substitution reaction, free radical substitution reaction. If it is this addition reaction, electrophilic addition, nucleophilic addition. Now, you can see this again substitution reaction, electrophilic substitution reaction. So, aromatic compounds undergo electrophilic substitution reaction and free radical, this is your free radical substitution reaction, alkane undergo free radical substitution reactions and nucleophiles also being substituted, that is nucleophilic substitution reaction आपको SN1 SN2 होगा and you are going to see addition reaction, it could be electrophilic addition reaction, alkene undergo electrophilic addition reaction and you can see carbonyl compounds undergo nucleophilic addition reaction. You know, free radicals can also undergo addition reaction like alkene with HBr in the presence of peroxides, right? And also elimination reaction. So, removal of an atom or a group and introduction of a pi bond is called as an elimination reaction. You see, this is a dehydrohalogenation. एक halogen and hydrogen हटा दिया. So, जिस कार्बन एटम में halogen हटा दे रहे हैं ना, वो अल्फा कार्बन हो रहा, इसका बगल वाला का जो बीटा कार्बन होगा. And these two are eliminated to form an alkene. And this is what is called as an elimination reaction. We have various types of elimination reactions. Unimolecular elimination reaction E1 and bimolecular elimination reaction E2 and elimination it is with conjugate base E1CB you can say and neighboring group participation also comes under this. In the NEET examination just E1 and E2 काफ़ी important है and you can have rearrangement reactions. So rearrangement reaction where an atom is changed from one place to another place to give rise to another group is called as a rearrangement reaction. You have various types of rearrangement reactions. Sometimes the carbocation itself undergo rearrangement. So, you can say, I want to discuss some important questions based on this. Electronic effect, we completed the electronic effects. Let us discuss some questions based on the electronic effects. Arrange the following compound in order of the basicity. So, when the question comes like this, basic order is directly proportional to availability of lone pair on nitrogen. So what happened? This is the lone pair and this is the lone pair and this is the lone pair and this is the lone pair. This is lone pair is delocalized and it is become aromatic, super busy and it is delocalized सिर्फ delocalize किया. It is not delocalized, but it is aromatic, and you have negative inductive. This is alkyl one. This is alkyl one. So I want to say alkyl amine is always more basic than not delocalized one, and delocalized one, super delocalized one. My answer for this question is going to be option 2. So this is the way the questions are being asked as far as the NEET examination is concerned. And let us see one more question based on this. Order of stability of carbocation. Dear children, this is your secondary carbocation and this is your tertiary carbocation. This is not possible, do not exist. Why? Because Bridge had carbon. Bread's rule का हिसाब से, so that one is least stable. One is least stable. So among them, second one is more stable than the third one because the tertiary carbocation and this is the secondary carbocation. My answer for this question is going to be D for this question. And arrange the following in decreasing order of basicity, basic strength. So basic strength is directly proportional to positive mesomeric effect or positive inductive effect, inversely proportional to negative mesomeric effect, negative inductive effect. And you can say this is your super mesomeric, super negative inductive effect. And this is going to be positive inductive effect. It is going to be positive mesomeric effect, negative inductive effect. This is going to be negative inductive effect, weak positive mesomeric effect. When halogen comes, I should consider only inductive effect. Whenever mesomeric effect and inductive effect, mesomeric effect is considered. And positive inductive effect and negative mesomeric effect is considered. So that you are going to see positive mesomeric effect, positive inductive effect, and it is going to be 1 and 2 is least. Because of the negative inductive effect, you are going to have 5 is the last but one. And this already we did it. Hyperconjugation occurs in. The question is based on hyperconjugation. Condition for hyperconjugation. Wherever alpha hydrogens are there you are going to see hyperconjugation. So alpha hydrogens are seen, it will show. Hyperconjugation can be seen here, it will show. And hyperconjugation is seen, it will show. So I want to show all of these is going to be the answer for this question. Hyperconjugation is shown. The answer for this is going to be D. Wonderful. So let's see one more question here. And the question, these are the resonating structures, the correct order of stability among this canonical structure. Dear children, in this canonical structure, carbon with a positive charge, octet nahi hai, oxygen with a negative charge and a carbon with a negative charge. So the order comes in this effect is going to be 3 is more stable, oxygen with a negative charge, and 2 is least stable, it is not octet. Therefore, my option for this question is going to be B is the correct answer for this question. Let's see some more questions based on this direct application of the electronic effects. Among these compounds, the order of heats of hydrogenation. Heat of hydrogenation is inversely proportional to stability. And the stability is directly proportional to hyperconjugation. Here you can see number of double bonds. Heat of hydrogenation 2 is more and 1 and 2, 3. 3 is least, only 1 double bond. So number of double bonds you have to consider, number of hyperconjugation you have to consider if the double bonds are same. I want to say the answer for this question is going to be 2 is more than 1 because here resonance is there, here resonance is not there. So that it is more stable, so that less heat of hydrogenation. And here 3, it is going to be just hyperconjugation. So it is 1 double bond, so heat of hydrogen kam se kam hoga. Moving ahead here, one more thing. The most stable canonical structure among this following is. So the most stable, carbon with a positive charge, carbon with a positive charge, carbon with a positive charge. You know, this positive charge is going to be stabilized by positive mesomeric effect. Here is also stabilized by positive mesomeric effect. Resonance is there now. So that it is going to be super stable and less than, not following octet. Here not octet, as this is not octet, it is going to be less stable. So I want to say the most stable, I just want to say 2 is most stable. Option C is the correct answer. Option 2 is most stable. I want to say B is the correct answer for this question. B is the correct answer for this question. And the question, this is the structure of pyrrole, this is the structure of pyridine, and this is the structure of aniline. Which of these are correct statement? 1 is more stable than 2, 2 is more stable than 1 and 3, and 3 is more stable than 1. Now I want to say here the stability, the basic strength. So it is aromatic वजह से. So pyridine 2 is more basic than 3 is more basic than 1 is the least basic, because the lone pair is super busy in making its resonance. Therefore, the answer for this basic on this logic is going to be 2 is more basic than 3 and 1. So my answer is this. Moving ahead, which of the following molecule resonance effect is not present? In order to show resonance, conjugation should be there, the molecule should be planar, and the resonating structure should follow octet rule. If you want to make it, yes, you can have this effect. Yes, correct. It can have. And if you want to make this structure like this, you are going to make a structure like this. So it is going to be NH3. So if that is the case, nitrogen can never be pentavalent. It cannot be pentavalent. 5 bonds are there. So this is not correct. It cannot have 5 bonds. Therefore, option B is the correct answer for this question. So the organic chemistry is a collection of use points, and it is going to give you a simple answer so that you can do is the best. And also, the most unlikely representation of resonance structure is again nitrogen cannot be pentavalent. 5 bonds are formed. Para-nitrophenoxidine. So nitrogen cannot be pentavalent, so that this structure is outrightly wrong. So option C is the correct answer for this question. So here the option C is the correct answer. Now students, we had a very good session on discussion of various electronic effects. And these effects makes a base of the organic chemistry. So we learned inductive effect, mesomeric effect, resonance, aromaticity, hyperconjugation, electromeric effect. Among all these effects, maybe one effect or multiple effects can work. So we have to decide which effect has to applicable in this particular given example. So if you apply all these applications, and you can just see actual correct crystal clear answer. Hope you enjoyed this session. Thank you very much. Thank you.